Now that you know how to measure angles and the angle addition postulate, we're going to move on to exploring other angle pairs. By the end of the lesson today, you should be able to identify special angle pairs and use their relationships to find angle measures. It's essential that you understand that these special angle pairs can help you identify geometrical relationships, and it's these relationships that can help you find the measures of the angles. The first angle pair we're going to discuss are adjacent angles. They are two coplanar angles, so they're in the same plane, with a common vertex, so they have the same vertex, and a common side, so one of the rays are the same, with no common interior points, so they do not overlap each other. The second pair of angles we're going to talk about are vertical angles. These are two angles whose sides are opposite rays. You might already be familiar with complementary angles. These are two angles whose measures total to 90 degrees. So you'll notice that 30 plus 60 is 90. And you will also notice over here that since we have a right angle, these two adjacent angles form a right angle, so they are also complementary. We know that their measures will total to 90 degrees. To go along with complementary, we have supplementary. These are two angles whose measures total to 180 degrees. So you'll notice over here that 72 degrees plus 108 degrees is 180 degrees. We also know that a straight angle has a measure of 180 degrees, so if two adjacent angles form a straight angle, they will also be supplementary. Let's apply what we have just learned. Are angle BFD and angle CFD adjacent angles? Well, they are indeed coplanar. That's one check. They do have a common side. That's another check. They do have a common vertex. That's another check. But notice that the BFD and CFD interior points do intersect. So that would mean no, they are not adjacent angles because they don't meet all 4 points of the definition. Next are angles AFB and EFD, vertical angles. Well, ray FA and ray FD are opposite rays. However, ray FB and ray FE are not opposite rays. And finally, are angle AFE and angle BFC complementary angles. Well, the measure of angle AFE plus the measure of angle BFC is going to equal 90 degrees. So, yes. And now it's your turn. Go ahead and press pause, answer these 3 questions, and then press play to make sure you're correct. So you have your answers? Excellent. How did you do? Now let's get right back to work with another definition. Linear pair. A linear pair are adjacent angles, so you'll notice that ADB and BDC are adjacent angles whose non-adjacent sides are opposite rays. So you'll notice that ray AD and ray DC are opposite rays. That means that angles of a linear pair form a straight angle or a straight line. And so now we have our next concept, the linear pair property. If two angles form a linear pair, then they are supplementary. Remember that in a linear pair, the non-adjacent rays are opposite rays. So that means that the measure of angle ADC has to be 180 degrees. So that also means the measure of angle ADB plus the measure of angle BDC has to equal the measure of angle ADC. In other words, two angles added together have to equal 180 degrees. That makes them supplementary. Let's put all these concepts together in one great big problem. What can you conclude from the figure and why? Well, let's start off with these marks, these little red marks that are sitting right here. that means that the measure of angle 1 is equal to the measure of angle 2, or that angle 1 is congruent to angle 2. Then we can move on to other things like adjacent angles. Then there are tons of adjacent angles. You like my abbreviation for angles there? Angle 1 and angle 2 are adjacent angles. Angle 2 and angle 3 are adjacent angles. Angle 3 and angle 4 are adjacent angles. Angle 4 and angle 5 are adjacent angles. And also angle 5 and angle 1 are adjacent angles. Now, I don't see any complementary angles in this figure. However, there are plenty of supplementary angles. And they are supplementary angles specifically because in this case, they are linear pairs. Angle 3 and angle 4 form a linear pair, and therefore they are supplementary. Also, angle 4 and angle 5 form a linear pair, so they are also supplementary. Does all of that make sense? Let's do something here that may help us out. There are some things that you can assume about figures that are true and some things that you can't assume, so I'm going to make a quick list here for you. First, here are some things that are safe to assume. You can assume that points are collinear, especially if there's a line drawn through them. You can assume that angles are adjacent. Combining those two statements, you can also assume that adjacent angles form a linear pair. And you can also assume that angles are vertical angles. Now let's talk about some things that are not safe to assume. It is not safe to assume that angles or segments that have not been marked are congruent. It is definitely not safe to assume that an angle is a right angle. It must be marked. Do not assume that angles are complementary. And finally, angles that are not a linear pair should not be assumed supplementary. Hopefully this list will guide you through the next set of problems. So this is where you press pause and work through these problems. When you have your answers, press play and make sure you are correct. So you have your answers? Great job. Here are the answers. How well did you do? Now let's apply some algebra to everything that we have been learning. Here we're told that angle KPL and JPL form a linear pair. So I'm going to quickly draw a linear pair here. And obviously, both of them have point P, so that must be a common vertex. And we have point K and L and J. So angle KPL and angle JPL form a linear pair. We're also told that the measure of angle KPL is 2x plus 24, and the measure of angle JPL is 4x plus 36. So now that we have a figure, it might be easier to write our equation. We'll use the angle addition postulate and say the measure of angle JPL plus the measure of angle KPL has to equal the measure of angle KPJ. That would be the whole angle. So now let's do some substitution here. The measure of angle JPL is 4x plus 36. The measure of angle KPL is 2x plus 24. And the measure of angle KPJ is 180 degrees. Remember that in linear pair, they form a straight angle, which has a measure of 180 degrees, so they are supplementary. Now let's do some algebra here. 6x plus 60 is going to equal 180 degrees. So 6x has to equal 120 degrees, subtracting 60 from both sides. And x is equal to 20 degrees, dividing both sides by 6. So that's step one, write and solve an equation. Now we're going to evaluate our expressions. So the measure of angle JPL is going to equal 4 times the 20 degrees that we found, plus 36. And of course, that is quickly and easily calculated as 116 degrees. And finally, the measure of angle KPL is going to equal 2 times that same 20 degrees for x plus 24. And that is going to equal 64 degrees. Okay, this time on your own, press pause, do these problems. When you have your answers, press play and make sure you're correct. So, you've got your answers. Compare them to ours. How did you do? We've come to the end of another lesson. Press pause. Copy these problems down along with the figure. After you get through copying these down, there's another set of questions on the next slide. So when you're done, check the next slide. And here are the last couple of problems. Remember, come to class ready to ask questions.